So, first question, we have a function here and use h10 equals 30 to show that p equals 3.6. So anywhere I see x, I'm going to replace it with 10. 0.1210 squared plus p times 10 plus 5. Now, the part I'm going to put into my calculator is all this part here. I'm going to throw all of this blue part here into my calculator. Okay, so I'm going to get a 0.001 times 10 cubed minus 0.12 times 10 squared, and then plus 5. And I get minus 6. Okay, so I'm going to get minus 6 plus 10p. Anytime I replace hx with 10, and the answer to that is 30. Then I'm going to bring the 6 over the other side. I'm going to get 10p equals 36. I'm going to divide 36 by 10, and I'm going to get 3.6. Happy days. Now remember, if you didn't get this right, you can still write down the new formula, because you know that p is 3.6x. So even if you didn't get the first part right, you still have all your information for the full formula in the next part. So I'm going to drag this formula to the next page. I'm probably going to need it. I'm going to move it over here. And look, it wants me to fill out a grid using this. So I'm going to use the table function. I'm going to go to my calculator mode, table function, and put all this in. 0.001 x cubed minus 12x squared plus 3.6x plus 5. I'm going to start at 0. I'm going to end at 70. And I'm going to go up in steps of 10. Okay, so I'm going to have 0, 5. Okay, we're going to have whoa, something went wrong here. Because I'm glad I have that 30 there, because something obviously went wrong. 12x squared plus 3.6x plus 5. Complete the grid below to show hk in the domain 0 to 75. Which I just did. Did I start off at 0? I'll enter in one more time. Just going to check back on me. 0.001 minus 0.12x squared, 3.6x. It's not 12. Shows you taking down the formula wrong can really sting you. And I was very fortunate to have the fact I could check the second one being 30. Plus 3.6x plus 5. Okay, start again. This time the second one's 30. So 0, 5, 10, 30, 20, 37, 30, 32, 40, 21, 50, 10, 60 is 5, and 70 is 12. Okay, now, fortunately for me, it's going to want me to draw all this in a second. Unfortunately for me, my graph's just that little bit too big, so I'm going to reduce this in size and use it to draw my diagram. Okay, so 0, 5 is here, halfway between 0 and 10, 10, 30 here, 20 and 37, that'd be 35, that'd be 37 and a half, so around there. 30, 32, around, sorry, underneath that line about here, 32, 40 and 21, just above the 20 mark, 50 and 10, 60 and 5, 70 and 12, around here, and finally 75 and 21.8, so that'd be 22.5, so around there. And you see we have ourselves a nice cubic function, a nice max and min. Okay, and obviously I can only draw this so accurate with my software. There we go. Happy days. Nice when you have to draw something, and it's pretty easy. Now, what does it want from me next? The function can be used to model the height above level ground in meters. So this function can be used to model the height above level ground. Okay, so in this diagram here, 0.5 would mean that if you're 0 meters across, you're 5 meters up in the air. And if you're 20 meters across, you're 37 meters up in the air. Something like that. Yeah. Where x is the horizontal distance from a fixed point. Find the first derivative. No hassle. Bring the 3 to the front, multiply by what's there, take 1 away from the power. Bring the 2 to the front, multiply by 0.12, take 1 away from the power. Drop the x and drop the 5. Show that the track reaches its maximum height above level ground at x equals 20. So we sort of knew that already, 20 and 37 sort of been the maximum height in our graph from earlier. I think that's meant to be our maximum there, so I actually should have been on my way down like this, and that's my max, okay? So what we're going to do is the slope will have to equal 0 at the maximum. So the first derivative will have to equal 0 as well. And once again, I'm just going to do the minus b formula. A equals, what's it, 0.003. B equals minus 0.24. C equals 3.6. And we're going to do the minus b plus or minus square root of b squared minus 4ac all over 2a. Now let's mode back to 1. No memory, unfortunately. So here we go. So minus b, so that's b. So minus b will be 0.24. So 0.24 plus square root b squared minus 0.24 squared minus 4 times a, 0.003 times c, which is 3.6, all over 2a, which is going to be 2 times 0.003, and you get 60. So that's x equals 60, but I think that might have been the minimum. However, for the maximum, we got x equals 20. Okay, let's go and check the markings. Now, to prove that it's actually a minimum, or so to prove that x equals 20 is the maximum, I should do the second derivative test and prove that it's bigger than 0. So the second derivative test is when the second derivative is smaller than 0, it's a max, and when the second derivative is bigger than 0, it's a min. Okay, so what we're going to do is 0.006x minus 0.24, that's the second derivative. So we're going to do second derivative, h double-20 is going to be 0.006 times 20 minus 0.24. Put that into the calculator, 0.006 too many zeros, 6 times 20 minus 24. And lo and behold, it's a negative number. It's minus 23.88, which is less than 0, which means max. And vice versa. If you did the second derivative for 60, and you proved that it was bigger than 0, you'd prove that it is a minimum. So sub in 60 here. Oh, that is also a minimum. So 60 is actually also a minimum. Yeah, it's actually 0.24. Ugh, such an idiot. That's 0.12, which is bigger than 0. And then on the first one, it actually wasn't that. It was 0.06 times 20, and that was minus 0.12. Minus 0.12 is smaller than 0. It is the max, so 20 is the max, and 60 is the min, because one of them's bigger and the other one's smaller. Right. Happy days. So that's question 7. Now, find using calculus the height above ground in meters at the instant the track passes through the inflection point. Now, it wants us to find the height above ground. So we need to get the x value, and then we need to get the h value. So we need to do the second derivative, because it says inflection point. So the second derivative equals 0. And we already have the second derivative. That's it here. I'm going to copy and paste this over. Cut, bring this up here. And paste, that's my second derivative. And this second derivative has to equal 0. So we're going to transfer that over to the other side. And we're going to get 0.006x. And then we're going to do 0.24 divided by 0.006. And we get an answer of 40. So we're going to get x equals 40. But please remember, they're actually after the height. So if we go back to the start, we know that 40 is actually a height of 21. So we can say that our height is therefore 21 meters above ground. Okay. Okay, so we're going to find the average height. Now the average height, when you see that keyword in a calculus question, you're going to be linking it to the average value of the function, which we all know is an integration. Okay, so the integration we're going to be doing here is going to be the integral of 1 minus b over a integral of ba f of x dx. Now it's not f of x this time around, it's actually h of x. So we're just going to sub in h of x here, so we're going to get 0.001 x cubed, and it's going to give us the average height of the roller coaster above ground. We can sort of get a rough idea from our diagram earlier. So if you look at your diagram earlier, sort of like it's almost like the average of all these values averaged up. Now it's not quite all these values averaged up, but all these values averaged up would give you a rough guideline of where the average is going to be. I'd imagine it's going to be somewhere around the 20 mark, somewhere would be the halfway region, but we're going to find that out pretty soon by using the integration method as shown. Okay, so here we go. So it's 0 to 75. So we're going to put 75 on top, 0 on the bottom, and it's going to be 75 take away 0. Okay, now we're going to integrate this. Add 1 onto the power, and then divide by the new power. Add 1 onto the power, so 0.12 x cubed, and that's going to be all over 3. But 3 into 0.12 is actually 0.04. So we can sort that one out right away. 0.04. Integrate this one, add 1 to the power. So it's x squared over 2. and then divide 3.6 by 2, and we're going to get 1.8, and then finally 5x, and we're going to do that from 75 to 0. Now let's throw in all these values here. Let's see what happens. So the first one, the zeros don't matter, because when you put in 0, everything's going to be 0. So we know the second bracket straight away is going to be take away 0. Now we're going to put in 75 into this one, so it's going to be 0.001 over 4, 75 to the power of 4. It's going to be minus 0.0475 to the power of 3. Then it's going to be 1 plus 1.8 plus 1.8, 75 squared, and 5 times 75. So interesting to see what this comes out as. So 0.001 times 75 to the power of 4 all over 4 minus 0.04 times 75 cubed plus 1.8 times 75 squared and plus 5 times 75. And that's a fairly big height now. And that's 1,535.1562. That's way higher than I thought it'd be, because I thought it'd be something like 20. But wait, I forgot something. At the very beginning, see this 1 over 75 on the outside? That's why we have a prediction in play. It's 1 over 75 on the outside, and it's going to be divide that answer by 75. And lo and behold, we get the answer of 20.47, which is roughly what I predicted earlier. And the answer to 2 decimal places, and we're done.